Hello, good afternoon once again. This is another edition of us here learning, and then we are here to start off with the cell injury. As I told you yesterday, we were able to finish with the surgery indications and the rest. So we looked at preoperative, intraoperative, and postoperative care yesterday, and we're able to finish that. So today we're looking at cell injury, and as I told you the other time, as we look into it very properly, we may appreciate each of the various topics that we'll be learning. So if you followed me carefully, I started with surgical, or let's say surgery and surgical indications. We talked about what surgery was. We looked at the purposes of surgery and the types of surgery that can be done. Then from there, we moved on to the theater setting and all that. So yesterday we handled preoperative and postoperative care and intraoperative care briefly. So meaning we've spoken more about whatever is at the theater and what can be done at the theater. So moving from there, we look at if an individual is taken to the theater, what goes on there if a patient is supposed to be sent to the theater. So we looked at the preparations that we can do for a patient prior to surgery, and then the preparations or the care or management that we can do for a patient after the surgery. Okay, so today we're looking at cell injury. Before every disease condition will emanate, it has to start from somewhere. And then the basis of all human life are cells. So from cells, we go to tissue. From tissue, we go to organs. From organ, we go to an organ system. From organ system, before we can get an organelle or a human being. So before an individual may severe an injury, may get a certain condition, diabetes, hypertension, whatever, anything that may happen within an individual, it is starting from the basis of the cell. So in a cell, there's a nucleus in the cell which we have an RNA and a DNA. So the DNA is the basic life concept. So that is what is going to tell the cell what the cell is supposed to do. That is what gives every cell its proper function. That is what is able to stipulate the differences within the cells. So if you have a skeletal tissue, meaning that we have cells that are making the skeletal tissue. If we have a muscular tissue, we have muscle cells that are making up the muscles. So everything is starting from basis of cell. So before an individual may have a certain condition, meaning that it is starting from a cell has been injured. So when a cell gets injured and nothing is done about it, it doesn't heal, then a whole tissue will be injured. So for example, if we have this cell and this cell is injured, similar cells coming together will give you a tissue. So if this cell, one of these cells, gets injured and then they work together. So if this one is injured, meaning that the function of this particular cell is no more available. So it gives these three cells load because they are supposed to perform an extra function of this. So if they have another function in addition to whatever that they are supposed to do, meaning that it gives them a working load. So there's a if this one doesn't heal, then meaning it may affect this one's work. So there will be a problem with this one. If this one also is affected, then there's a problem with this one, so on and so forth. So by the time you realize this whole cell that is giving you a tissue, a whole tissue has been affected. And similar tissues give you an organ. So let's say this is another tissue. this is another tissue. So this whole tissue gives you an organ. So this is a tissue, and these are cells. So if this whole tissue is affected, these tissues are supposed to work hand in hand. So if this tissue is affected, the meaning that is going to affect this tissue is going to affect this tissue as well. So meaning the whole organ will be affected. So organs that perform similar function will give you an organ system. So let's say that's the circulatory system. So it has the heart and then the blood vessels. So if let's say a blood vessel is affected, or let's say some of the blood vessels are affected, there's a possibility of the heart also being affected. If the heart is affected, there's a possibility of the blood vessels also being affected. So if an organ becomes affected, the other organs that are related to that specific organ. So let's say the urinary system, where we have the kidneys, we have the ureters, we have the urinary bladder, and then we have the urethra. So if the kidneys are affected, it is in relation to these ones. There is a possibility that the whole function of the urinary system may be affected. So if the whole urinary system becomes affected, so meaning that the system has been affected. If this system becomes affected, there are other systems that are relating to that same system. So there's a possibility that other parts, so let's say the urinary system work hand in hand with the circulatory system, or the reproductive system. So sometimes we can say genitourinary system, the genitals and the urinary system. So we say genitourinary system. So meaning that if the urinary system is affected, then the reproductive system may also be affected. Then the circulatory system may also be affected. So by the time you realize, because of an injury to just one cell, the whole system has been affected. So whenever we talk about cell injury, meaning that we mean a broader perspective, meaning that for all conditions, they emanate from a disruption of a cell or an injury. So when we get further, we look at Rodolphe Virchow spoke about cells being the building blocks of everything that human beings can talk about. So now we move on to what a cell injury is. So we look at it from this angle. Our learning objectives for cell injury. At the end of the lecture, a student should be able to explain the cellular basis of disease. That is, every disease is caused by a cellular differentiation, a problem with a cell. And then explain homeostasis and the steady state, for which we will talk about. Discuss factors that affect cellular responses to abnormal stimuli. State and explain the various types of cellular responses to abnormal stimuli. State and discuss the causes of cellular injury. What causes an injury to a cell? Classify the morphologic types of cellular and tissue adaptation processes, how cells and tissue are able to adapt when there are injuries. Explain the processes and mechanism involved in cell and tissue adaptation. When there is an injury, how do the cells adapt so that they can heal themselves? Explain the functional alterations associated with each type of adaptation. So we look through, or we go through the adaptation processes, and we look at what they mean and how cells can go through such processes to be able to adapt to stresses. So cellular basis of disease, how a cell is the base of almost certain conditions or diseases that we talk about. All diseases are, in the last analysis, reducible to disturbance, either active or passive, of large groups of living units, which are cells, whose functional capacity is altered in accordance with the state of their molecular composition and is thus dependent on physical and chemical changes of their content. What we're trying to look at is that cells comes together in a unit to perform similar or same function before they are able to be called a tissue. So if there is an alteration in their component, so meaning that whenever you have a cell and then there's a problem with the component of cell, for which I know you know the component of cell, the cytosol, the nucleus, and the various organelles. So meaning that when there is a disturbance in any of these organelles, in the cytosol, in any part or the nucleus of a cell, meaning that the cell will have a problem, it is going to alter its proper function. And whenever we have an alteration in the function of a cell, meaning that they are not going to do the work that they are supposed to do. So Rudolf Virchow in 1855 found out that the cell is the unit of life. The unit to which human beings live is a cell. Thus, according to Virchow, the abnormality in a disease must be looked for in a cell. So every abnormal thing that we are going to find in an individual should be looked for in a cell because the cell is the unit of life. So before any other thing happens within an individual body, it emanates from the cell. It is starting from the cell. The normal cell. So now we quickly look at what a cell is, and then we try to describe it a little bit before we can continue. Cells are the basic unit of tissues which form organs and systems in the human body. So the basic unit of a human body is what is a cell. Traditionally, body cells are divided into two main types. Traditionally, we have epithelial cells and mesenchymal cells. In health, the cells remain in accord with each other, meaning that they perform their normal functions with each other. They look at their main roles with each other. So when a portion of a cell is detached from each other, meaning that there's a possibility that they are not going to work. So epithelial cells and mesenchymal cells work hand in hand because none of them may exist without the other. So this is a proper cell. If we look at this cell, we are able to note certain things. So we're looking at the cell, the nucleus of the cell, the fluid that is found in the cell we term as cytosol, and then we have the organelles that are found in it. According to Virchow, he said that whenever there is a disturbance in any of these cells, organelles, either the nucleus, the cytosol, or let's say the organelles that are found. So unless you don't know the functions of each of the organelles that are found within the cell, that is where you'll be able to argue. So for example, the nucleus of every cell contains DNA, which controls the cellular activity, plays a central role in heredity. So if there's a problem with the nucleus, meaning that which is going to be the control center of the cell, which one is going to play an essential role in heredity. So if you look at the basis of heredity, we have certain things we call chromosomes. We have 46 chromosomes or 23 pairs of chromosomes. Out of the 23 pairs of chromosomes, 22 are termed autosomes. And with these autosomes that we are talking about, 22 are termed autosomes and one sex chromosome. Meaning that the determinant of every individual, whether male or female, is just a pair. So therefore, the 22 autosomes are heredity traits, and we have only one sex cell. So the sex cells are the last portion of the chromosomes. So for a female, you can have an X and an X for female. With a male, you can have a Y and an X. So genetically, every human being starts off with being female. So every female has two X's, and the male has an X and a Y. So the determinant of a gender is dependent on the father, because regardless of whatever happens, every female brings an X. So if the mother brings an S and the father comes with an X, you have a female. If the mother brings an X and the father brings a Y, you have a male. This is what is found in the DNA. So if there's a disturbance in this, whereby there is no X, so you have X and 0, then there is a problem. This person will be a female, but the person is going to have deficiency in other things. Why? Because they do not have a complete. So instead of the 46 chromosome, the person is going to have a 45 chromosome, which is not up to the 46 chromosomes. So invariably, within the cell, the DNA of the cell even shows us that that is where hereditary structures are supposed to take place. With these 22 autosomes, that is what we inherit from both parents, so from our mother and from our father. So hair, eye color, skin color or complexion, baldness, tallness, shortness, that is dwarfism, whatever that we may call it. All these things are inherited from these other 22 autosomes. So these are sex determinants and these are autosomal determinants, or they are non-sex determinants, but they are characteristic trait determinants. They determine how individuals should look like. So you pick certain characteristics from your father, you pick certain characteristics from your mother. So all these things are dependent. So here, if there's a problem in the structure of the autosome, and then they go in pairs. So you pick one from your father, you pick another one from your mother. Pick one from your father, you pick another one from your mother. So with these autosomes, if you pick a characteristic trait, one that you may pick may become dominant or recessive. So if you pick more from a mother, you are going to look like your mother in certain ways. If you pick more from your father, you are going to look like your father in certain ways. So we have dominance and recessiveness as far as the autosomes are concerned. So for which it contains the hair, the eye color, the skin complexion, hairlines, and all those things that are applicable so far as chromosomes are concerned. So as we see, if the nucleus of the cell is not available, meaning that all these things cannot happen, meaning that you are not going to have an accurate human being. So you bring a child out, the child may be a Down syndrome child, autistic. All of these things happen as a result of a disjointed fashion or pattern which happened within the DNA of the child during the process of fetal or fertilization or fetal generation or development. So even just the DNA within a cell can affect a child. How much more the whole cell when it becomes affected. So as we go back to this diagram, so now we know what the DNA is. When we look at something like the Golgi apparatus, which you see here, the Golgi apparatus on this area, what happens is that it modifies and distributes secretory products. So anything that is secreted, waste product that is found within the cell, that is what is the function or the responsibility of the Golgi apparatus. Ribosomes, what they do is that they are important in protein synthesis. They contain concentration of what? RNA. So meaning that whenever there is a protein in the cell, it is the responsibility of the ribosomes to be able to synthesize it. So cytosol is the intracellular fluid that is found within. That is what is making sure that these organelles don't knock each other. Mitochondria, the cell's power plant, that is the powerhouse of the cell, the energy. So the area to which the cells need much energy to be able to perform its proper function is dependent on the mitochondria. So if you look at all these parts of a cell, for which I know you have studied it very well, meaning that if any of these organelles are absent, meaning that a specific function may not be performed properly and well. So in such circumstances, meaning that the cell is inappropriate, the cell is inadequate to be able to perform a specific function. And in such a situation, there's a possibility that the cell will be injured. So for example, if the cell has no fluid, how do these cells or organelles in the cell move about? They can't move about, they can't perform their function because there's no fluid. And as a matter of fact, it will shrink the cell. So when a cell shrinks, meaning that it has changed in its form and function. So meaning that the proper function that the cell was supposed to have, it is no more having it now. So meaning that even right from the basis of a cell, every organelle, everything that is found within the cell, it is very important. So if this cell, anything happens within the cell, if a cell loses its ATP, adenosine triphosphate, which is the energy which is produced in the cell, meaning that the cell is not going to have energy again. If a cell loses its nucleus, meaning that the cell itself cannot stay. If a cell loses its membrane, if its membrane is ruptured, meaning that the organelles that are going to be found in the cell are going to die or they are going to escape. So meaning that if we look at the cell, it is very important for us to be able to know its function and its relation to diseases, as we want to talk about. So every cell has got certain effect in a tissue. So they perform similar or same functions. That is why they form a tissue. So if there is a disruption in the proper maintenance of this cell, meaning that there's a possibility that there's going to be an effect or a negative feedback to this cell. Let's look at the different regenerative capacities of cells. After injury, cells are able to regenerate. That is why whenever there is a wound, and after some time, it will heal. And when it heals, the skin goes back to its normalism. So, different cells have different regenerative capacities. There are certain parts of the body that can regenerate back after they have been worn out. There are certain parts of the body whereby the cells over there can never regenerate again. So we have three main different types of cells according to their regenerative capacity, according to how they'll be able to replicate themselves. So one, we have something we call larval cells or primary stem cells. The next one is stable cells or stem cells and differentiated cells. The third one are permanent cells, that is few cells, few stem cells and or differentiated cells. So when we talk about larval cells are primary cells. That they are the cells that are able to regenerate throughout your life. An example is the superficial layer of our skin, the mucous lining cells, hematopoietic cells, stem cells. So here, whenever you severe an injury to the skin, see that after some time it regenerates. You have a scar. At some point in time, the scar goes off and then your skin becomes normal again. Why? Because there have been granulation tissues that have been able to fill the worn out tissues. There have been a replication, there have been a regeneration of the cells again. With stable cells, they replicate, but they replicate slowly or at low level throughout the life and have the capacity to divide if stimulated by some initiating event. Example includes hepatocytes. When we talk about hepatocytes, we are talking about the liver cells, proximal tubule cells, endothelium. So a typical example is the hepatocytes, the cells that are found in the liver. It's a stable cell. They regenerate, but they do not regenerate fully. So, for example, if you can have the liver in this context, and then a part of the liver is diseased and it is cut off. So in regeneration, you are expecting this same thing regenerating back again. But because it's a stable cell which has a low level of regeneration, it will be able to regenerate, but it's not going to regenerate as you wish it could. So probably it can regenerate up to this area only. So meaning that this area has been cut off. So instead of having a full liver like this at the end of the injury, this is what is going to happen. The hepatocytes, the cells that are found in the liver, cannot fully regenerate. So this is the type of organ that you'll be having at the end of the injury if there's a problem. So in this manner, if an individual has a problem with the liver, we can cut someone's liver, a portion of it, and transplant it to the individual. So let's say that if we can have this sort of liver transplanted to the individual, at the end of the day, we can have something like this, which is going to be enough for the individual to live on for some time. So that is the stable cells, meaning that they replicate themselves low, or they have the tendency to replicate themselves slower throughout an individual's life. So the capacity to which they have to replace themselves are very low, and sometimes they do not replace themselves to its full. Permanent cells, few stem cells and or differentiated cells with very low level or no replicability capacity. They do not have replicative capacities. Examples include neurons and cardiac muscles, the heart, the muscles of the heart, neurons, those nerves that send impulses to the brain, communication to the brain. That's why when an individual goes into stroke, they are not able to return back to their normalism. Why? Because those cells are permanent cells. So those cells, we cannot replicate them, we cannot make them. So if they die, they die. So meaning that if any cell in the brain dies, that is that. And as we know, the brain is the center of the human being. If you lose your brain, you have lost everything, because every coordinative activity that is supposed to happen within the individual body starts from the brain. Before you see, you have a portion in the brain. Before you talk, you have a portion in the brain. Before you move, you have a portion in the brain. Before you think, before you eat, everything, temperature regulation, everything as far as human beings are concerned is placed in the brain. But unfortunately, if a cell or a nerve dies in the brain, it is permanent. Permanently, it is dead. It is not able to replace itself. Alright. Alright. Hello? I know. I know. Okay. That's it. So with cardiac muscles, what they do is that they replicate very slowly. They are not able to come back together. So it's like one characteristic of muscle are elasticity. So when they overstretch and they lose their elasticity, that is all. They are not able to come back again. So for example, if you have a boxer and the boxer is overstretched, it has been worn by someone very fat, meaning that the muscles have overstretched. There's no way you'll be able to bring that boxers back to its normalism as it used to be. So some of the permanent cells include the neurons and the cardiac muscle. So we talk about homeostasis and steady state of cell. At every point in time, the internal and external environment of every cell is supposed to be in equilibrium. They are supposed to be what they are supposed to be. They are not supposed to be any form of imbalances. So cells are restricted to a fairly narrow range of function and structure by their genetic program of metabolism, differentiation, and specialization. So the shape of every cell is determined by what they are supposed to do. So the size of cells is determined by what they are supposed to do and their specialization, their specialized area. Cells are also affected by the activity of neighboring cells. So that is why we have similar cells. When they come together, they form a specific tissue, because the activity of this cell that is closer to me, I'm supposed to perform a similar function with it. Either than that, we can't stay in one room. Cells exist in an external environment that requires continuous work against chemical gradients with energy expenditure to ensure that their internal environment or milieu can be closely maintained. So there's supposed to be a sort of energy outside the cell, which is supposed to help and coordinate and make sure that anything that is coming out of the cell is very regulated. Because if we don't take time, by the time we realize, a lot of things in the cell are coming out if we don't regulate them externally, or certain things are going into the cell if we don't regulate them. So we call something semi-permeable membrane. So it's not everything that can enter or come out of a cell. So it's supposed to be regulated. If it is regulated in that manner, meaning that that cell is going to be very stable. Constantly need to degrade and replace intracellular molecules which have reached the end of their shelf. So constantly, cells are supposed to be replacing intracellular molecules such as potassium, phosphorus, proteins, anything that constantly are leaving, energy, all these things that constantly are leaving, they are supposed to be replaced so that they can still be in their steady state and a comfortable state. All these require the availability of metabolic substrates. Good health depends on the ability of the body cells to adjust to this constant change and to maintain normal function and structure within these constraints. So it is the responsibility. So looking at every metabolic substrate, every metabolic changes, everything as far as environment, food, anything that we do to the body is concerned. For us to be able to have a proper health or good health, it is the responsibility of the body to be able to adjust to these changes that may happen to it, because it is not going to be in regular form. So let's say that if the body produces 50% of fluid, it's not going to be regular. Today it might be 60, today it might be 40, today it might be 30. So meaning that in such instances, they're supposed to have a flow, a proper flow of how the body is supposed to adjust to itself due to several changes and constraints. So the tendency to maintain relatively constant condition in the internal environment of cells is called homeostasis. So if we are able to maintain an internal environment, we are able to ensure that metabolic substances that are found within the cell are balanced. We don't allow things to move in the cell quickly and allow things to move out of the cell at any time without proper regulation, meaning that we are maintaining the internal environment or internal milieu of the cell. So in such a situation, we term it as homeostasis. Also refers to the narrow range of cellular responses to normal physiologic stimuli. So the normal cell exists in the steady state, which involves maintenance of homeostasis. So the normal cells will be in a very steady state and comfortable state if we maintain a proper homeostasis, which is constant condition of the internal environment of the cell. The steady state may alter in response to stimuli that are greater in intensity, extent or duration than those normally experienced. So it depends on the pressure on the cell. It depends on the pressure within the cell. So if they are too much, there's a possibility that that steady state may not hold for long. There may be alterations in that. So thus, cell control systems are critically important for optimal function and survival of the cell. So how the cell will be able to control itself, it is very important for the survival of the cell. If the cell is able to adjust to certain constraints, they are able to survive. Ill health or disease results when cells fail to maintain homeostasis in the face of adverse conditions. So when there are certain stresses, when there are certain constraints, when it gets access to the cell and the cell are not able to maintain an internal environment to suit them, to be able to adjust to the conditions, meaning that an individual may go ill. So as we said, cellular basis of diseases. So when cells becomes ill, tissues become ill, organs become ill, and then signs and symptoms start to emanate. Thus, poor response of cells to abnormal stimuli results in disease. So if a cell is not able to respond well to certain abnormal stimuli such as trauma, injury, or any other thing, inadequate substances or metabolic substances or substrates in it, meaning that it may result into a disease. The alteration in steady state may be reflected by molecular or genetic, biochemical, physiologic, or structural changes in various combinations. So how unsteady the cell will be will depend on the molecular changes, the genetic changes as we spoke about in the DNA, biochemical changes, any substance which flows in and out unsteadily within the cell, the physiological changes if the nature of the cells, the shape of the cells starts to change, if there are structural changes that is happening within, or let's say a combination of these factors will render the cell not to respond properly to its steady state. So now let's look at a cell injury. Definitions. When the cell is exposed to an injurious agent or stress, a subsequent of event follows that is loosely termed a cell injury. So when a cell is exposed to an injurious agent, stress, or anything that they cannot handle, meaning that we're looking at a cell injury, meaning that the cell is injured. So let's say trauma, any other thing, excess stress that they cannot handle. Let's say there are 4 cells and one is dead, so meaning that the others are supposed to take the load of the other, meaning that it's excess stress. So meaning that there's going to be an injury to that cell. Cell injury is reversible up to a certain point. So when a cell gets injured, like a skin gets broken, it can heal back. So meaning that the cells have been able to regenerate. So cell injury is reversible up to a certain point. But up to a certain point, it becomes irreversible. And when it becomes irreversible, the cell will die. And we'll look at some types of cell death and what effect cell death has on the individual. If the stimulus persists or is severe enough from the beginning, the cell reaches a point of no return and suffers irreversible cell injury and ultimately cell death. So when the stress becomes too much, when the injury from the beginning is severe, meaning that there's a possibility that the cell at that point in time may not be reversible, but it goes or suffers irreversible cell injury. And if it goes into irreversible cell injury, ultimately the cell will die because it cannot heal itself again. So what is cell death then? It is the ultimate result of a cell injury. That is the last thing that human beings can ever find on earth, to die. The same thing. So the last thing that we are expecting within an individual body when a cell is not able to heal itself is death. So when a cell dies, meaning that it gives the other cells other load for them to be able to what? Deal with. And if they are also not able to deal with the load and they go through strenuous activity, constraints and extra stresses, they also die. So when they die, you see that all the cells within that specific tissue will die. And so the whole tissue will be affected. If the whole tissue is affected and is also not corrected, an organ becomes affected. If an organ becomes affected and it also not corrected, an organ system becomes affected, and then the whole body, and then the individual dies. Cell injury is defined as a variety of stresses a cell encounters as a result of changes in its internal and external environment. So as I said, we call something semi-permeable membrane. So that is what the cell has. So it doesn't allow everything to come in and everything to go out. They are able to sort out what is supposed to come in and go out of the cell. So at some point in time, when all these things are not regulated, anything just goes in the cell, anything just comes out of the cell, meaning that within the cell, out of the cell, there is no proper coordination, meaning that there will be changes. So whenever there are changes, meaning that the cell will be injured. So Virchow in 1859 brought about something which we call the Virchow cellular theory of diseases. Diseases occur due to abnormalities at the level of the cells. So as he said, every human being is emanating from a cellular base. So for a disease to be able to emanate, meaning that a cell has been injured, there has been a problem with a cell, so which needs to be corrected. So the cellular response to stress may vary and depends upon the following. So the type of cell and tissue involved, extent and type of cell injury. So as we started, we said that we have epithelium and then mesenchymal cell. So the type of cell and tissue that is involved, the extent and the type of injury. So the cellular response, how a cell will be able to respond to a stress, may vary. So let's say we have skeletal cells and skeletal tissues. Okay, we have muscular cells and muscular tissues. Okay, so all these things are different types of tissues. So meaning that they are coming from different sorts of areas. So if any of them are stressed, it depends on the type of cell and then the tissue that is involved. That is what we will be able to know if that specific cell will be able to respond positively or negatively to the stress that is coming to it. And then the extent to which the cell has been injured, and then the type of the cell injury. So sometimes, as we said, cell injury can sometimes be reversible up to certain points. At certain points, they cannot be reversible again. So this is a cellular response to cell injury. So the effect that may be on a cell, the duration of the injury, this is it. So if the cell is able to move up to this portion, this area, all this area is a reversible cell injury, meaning that the cell can go back to its normalcy, it can be healed. If it moves from this area and eats into this area, nothing can be done about it. So you can see irreversible cell injury. So here what will happen is that if it is irreversible, there's going to be cell death. But before there's cell death, we are going to have a gross morphologic change, meaning that the cell type is going to change. So let's say a cytosol is out of a cell, there's no fluid. It's going to shrink the cell, meaning that the size and the shape of the cell is going to change. Light microscopic changes will happen. Certain things that cannot be seen with the naked eye is going to happen, especially when you have adenotriphosphate, that is the energy out of mitochondria. On structural changes, there are certain changes that are unstructured, you don't know where they even came about. When all these things happen, then the last portion that you can get is cell death. Etiology of cell injury. What causes cells to get injured? Someone may ask. Genetic causes and acquired causes. So with genetic causes, we may have developmental defects, errors in morphogenesis. So developmental defect, genetically, as we said, that it is the responsibility of the DNA to be able to code all these. So we have 22 autosomes and one sex cell. So during the processes of development, maybe there's a developmental malformation which is coming from the parents. Okay, so maybe an extra chromosomes may have, trisomy may happen, Down syndrome, Klinefelter syndrome, any of these things are chromosomal abnormalities, but they are errors. Cytogenic defect, chromosomal abnormalities, as we talked about. So developmental defects and chromosomal abnormalities. Single gene defect. So let's say that a sex cell or an autosome may be defected. There's going to be a problem with a specific chromosome or a specific cell. So the gene, which is the unit of trait, which is transmitting trait, may be defected. So if it is defected, an individual may not be having an eye, an individual may not be having a hand, an individual may be having a deformity in the part of the body. So we call it Mendelian disorders. I think you did that in social sciences. Multifunctional inheritance disorders. There are certain conditions that are inherited. So genetically, as far as you are part of those or that family, there's a possibility that you are going to develop those conditions. It's a fact because it's inherited. You can also have a cell injury as a result of certain acquired causes, hypoxia and ischemia, which we'll be explaining them soon. Physical agents, chemical agents and drugs, microbial agents, immunologic agents, nutritional derangement, aging, psychogenic diseases, iatrogenic factors, and idiopathic factors. So let's look at the acquired causes. Acquired causes, hypoxia and ischemia. When we talk about hypoxia, we simply means inadequate oxygen supply to a cell or tissue. So we can say hypoxia or anoxia. But it came about as a result of lack of blood supply. So inadequate blood supply to an area, we call it ischemia. But if a cell or tissue doesn't have enough blood supply, then we term it as hypoxia. So inadequate oxygen in a cell or tissue, we term it as hypoxia or anoxia. But if it comes about as a result of poor blood supply to an area, so poor blood supply to an area, we term it as ischemia. So we know blood contains oxygen, carbon dioxide, other nutrients, and blood itself, and other components of blood, white blood cells, red blood cells, platelets, and all those things. So physical agents, mechanical, chemical, electrical injury, when you have said acid pouring on you, when you hit your hand with a nail or whatever that it may be. Chemical agents, medication, smoke, drugs, etc. Microbial agents, bacteria and viral or fungal infections. Immunologic agents, double-edged sword hypersensitivity reaction, anaphylactic shock, infections, shocks that happen as a result of what? Infections. Nutritional derangement, both reduced and in excess. So when we talk about nutritional deficiency, people are always, or let's say malnutrition, people are thinking about only deficiency, but excess is also malnutrition. So they say too much of everything is bad. So it's either reduced, deficient, or excess may cause a cell to get injured. Aging, decreased ability for cell repair. When you are aging, your cells are losing the ability for them to be able to replicate. So when a child has a wound or a normal adult has a wound and an aged person also has a wound, the possibility that the aged person wound will not heal earlier is high. Why? Because as you age, the ability of your cells to be able to repair themselves starts to diminish. Psychogenic factors, anything that has to be psychological, whereby there's a release of certain hormones, prostaglandin, histamine, and certain pyrogens such as interleukins may also affect. Idiopathic diseases or causes, and then we can also talk about idiopathic. When we talk about idiopathic, meaning that unknown. When we talk about iatrogenic factors, we're looking about any factor relating to illness caused by medical examination or treatment. Let's say you are given drugs and the side effect of the drugs may lead to certain conditions. Okay, so that's what we say iatrogenic. Okay, so iatrogenic condition, you are giving drugs, the patient has a condition, and you have given the patient certain medications, and those medication may lead to certain diseases. So for example, prolonged administration of aspirin like this may lead into gastric ulcers. Prolonged administration of aspirin or NSAIDs may lead to gastric ulcers. So most of the time, when an individual is going to be on NSAIDs or non-steroidal anti-inflammatory drugs for a longer period of time, certain agonists are added to it so that it can have a positive effect. And as I said, idiopathic is unknown causes. So let's take it one after the other. Oxygen deprivation, hypoxia. If oxygen is deprived in a cell or tissue, we term it as hypoxia. But what may cause the hypoxia? As a result of ischemia, which is loss of blood supply to an area, inadequate oxygenation, that is cardiorespiratory failure, the circulatory system and the respiratory system coming together. So I told you that certain organ systems may be playing similar roles. So for example, before blood may receive oxygen, they are supposed to go to the lungs, whereby exchange of gases takes place in the lungs and then they are brought back to the heart again. So meaning that if there's a collapse of lung, meaning that exchange of gases will not take place. So whatever blood that is going to circulate through an individual is not going to be oxygenated. So it's not going to be oxygenated. So we are going to have deoxygenated blood running through, which is also bad. So we need proper blood supply to the various parts of the body. So loss of oxygen carrying capacity of the blood. So if an individual has anemia or carbon dioxide poisoning, meaning that the capacity of which the blood should be able to carry oxygen is very low. So these are some of the causes of hypoxia. So hypoxic injury may come about when there's a loss of oxidative phosphorylation and ATP. So phosphorus is out, ATP, adenosine triphosphate, which is the energy generation which is found in the mitochondria, when it is lost, meaning that you are going to have a hypoxic injury. Decrease ATP with increased AMP. When your ATP is decreased and your AMP is what? Increased. Stimulating fructokinase and then phosphorylation, resulting in anaerobic what? Glycolysis. So we'll be talking about these things soon. Depleted glycogen, reduced intracellular pH, that is lactic acid and inorganic phosphate, clamping of cellular chromatin. Okay, so when the chromatin, the spindle fibers are clamped. So physical agents, trauma, heat, cold, radiation, electric shock are physical causes of cell injury. Chemical agents, drugs, endogenous products such as urea, exogenous agents, therapeutic drugs, hormones, example hormones, non-therapeutic agents, lead or alcohol may also lead to a cell injury. We call something free radical initiation. When we talk about free radicals, we're looking at other sources that may be able When we talk about free radicals, we're looking at an unchanged molecule, or let's say other source, as I said earlier, which may have an unimpaired valency on electrons. Okay, so how they are going to work, how they are going to help the body to be able to move in a stable manner. So free radicals are most of the time unstable molecules that can damage the cells in your body. So there are certain molecules that are found within the cell. Okay, when they are unstable, when they are supposed to leave the cell and they are not able to leave the cell, then they damage the cell. Okay, so when we talk about free radicals, we are looking at unstable molecules that can damage the cells in your body. Okay, so for example, they form when atoms or molecule gain or lose electrons. So we talked about this chemistry thing, atomic covalent bonding and ionic bonding and all those things. So we didn't go into details on that. So free radicals. So example, absorption of energy, UV light and X-rays, excessive of X-rays kills a lot of cells, because one X-ray kills thousands of cells, because we are supposed to have a proper imaging. But just that the body is able to replicate itself, the cells are able to replicate themselves, so we don't see it. Oxidative metabolic reactions. Okay, oxidative metabolic reaction as a result of oxygen intake, and then there's supposed to be certain metabolic balances that is supposed to be found within a cell. So the molecules over there, they find themselves outside instead of inside, or inside instead of outside. Enzymatic conversion of exogenous chemicals or drugs. So when enzymes are supposed to convert certain exogenous chemicals, okay, and they are not able to convert these chemicals, and these chemicals are left within the individual's body. So oxygen derived radicals, some of the radicals or the free radicals that we talk about as molecules here, they derive their source or their existence from oxygen. So meaning that there's going to be a deprivation. And superoxide, whenever there's too much superoxide in the individual. Infectious agents. Virus, rickettsia, bacteria, fungi, parasites. All these are infectious agents that has effect in the individual body when they get access. So therefore, the cells are injured. Abnormal immunological reactions. The immune system process is normally protective, but in certain circumstances, the reaction may become rearranged. So it is the responsibility of our immune system to be able to be activated and heal us. So hypersensitivity to various substances can lead to anaphylaxis or to more localized diseases such as asthma. In other circumstances, the immune processes may act against the body cells, autoimmunity. So here your white blood cells will be fighting against your own cells. Why? Because they are immunocompromised. So there are certain things that may have effect on the body that it may put the body into a different form for which the immune system of the body may be fighting against it, especially when they have seen something foreign in the body. Nutritional imbalances, protein calorie deficiencies are the most examples of nutritional deficiencies. Protein, kwashiorkor, and beriberi, that is the most nutritional deficiencies that we may have. Vitamin deficiency may cause a cell to get injured. Excess in nutrition are more important causes of morbidity and mortality. Excess calories and diets rich in animal fat are now strong implicated in the development of atherosclerosis. Obesity alone leads to an increased vulnerability to certain disorders such as atherosclerosis, coronary heart diseases, and diabetes mellitus. So nutritional imbalances may cause all these things to injure a cell. Aging, programmed aging, whereby after a defined number of divisions, the cell undergoes terminal differentiation. As you are aging, your cell undergoes something we call terminal differentiation. So some of them will be dying, a little will be replicated, some of them will be dying. That's what brings about shrinking of the skin and all that. Development of an increasing population of cells, irreversibly committed to census and death. Okay, censuses and death. So whenever you have this increasing population cells that are dying and they can never be reversed, meaning that the individual is moving gradually to their grave. Increased susceptibility to somatic mutation and a build-up of errors leading to an eventual error catastrophe. As we said, it is the responsibility of the DNA to be able to code all cells so that they can have a proper function. So if an individual is aging, meaning that you are susceptible to somatic mutation, any other way to which the cells can be able to manipulate is very high. Faulty DNA repair mechanism. Whenever there's a cell injury, it is the responsibility of the DNA to be able to repair itself so that the cells can be repaired because they have given wrong error, which brought about catastrophe in the cell development. So what happened is that it is the responsibility of the DNA to be able to repair the cell whenever cell goes through injury. But if the DNA is repairing the cell in a faulty mechanism, in a faulty way, they don't go through the normal channel or the normal processes, maybe then there's going to be a problem. Cells react to adverse influences. So when a cell is injured, they react to influences. They are influenced easily. So they are influenced in three main ways. They either adapt, and after adaptation, they become reversible or they go irreversible. So if there are external stresses, if they are constrained on a cell, they go through cellular adaptation processes. And we have 5 main cellular adaptation processes: hyperplasia, hypertrophy, atrophy, metaplasia, and dysplasia. Hyperplasia, hypertrophy, atrophy, metaplasia, and dysplasia. If they go through reversible injury, after adaptation processes, the cell is still injured and something can be done about it. They go through intracellular edema. Okay, so within the cell, they swell. Fat change, they change the rate at which fat is accumulated. And then hyaline change, they also change in that form so that they can be reversible. They also amyloidosis, we will look at them. Mucoid degeneration, pathologic pigments also happen. So lastly, then they can move to irreversible injury and dying. So in irreversible injury, cells go through these processes: necrosis, gangrene, followed by pathological calcification, hardening. Pathological calcification, hardening. So we're taking it one after the other. Cellular response to adverse effect. If a cell gets injured, they go through this channel. A normal cell homeostasis, which a cell is in its internal and external environment, everything is normal. Whenever they are stressed, there's an increased demand. So meaning that the cell will have to adapt to the increased demand, as we said earlier. When they are not able to adapt, they become injured. So meaning that inability to be able to adapt to those adaptations, they become injured. When they become injured, they go through certain things. They become reversible. So in the form of reversibility, they have subcellular alterations. They alter certain things. So those dead things that are supposed to be excreted out, they are excreted out and all that. If it goes through reversible cell injury and at a point it becomes irreversible, then we go into necrosis. So necrosis simply means the death of a cell or cell death. It can also move. Another form of irreversible thing that we can also talk about is apoptosis, programmed cell death. So we also go through that, apoptosis or apoptosis. So cellular adaptations. So types of cellular adaptations. We can have two main types of cellular adaptation. We can have a pathologic adaptation and cellular adaptation. But what we are coming to talk about is cellular adaptation. So with pathologic adaptation, may share the same underlying mechanism, but they provide the cells with the ability to survive in their environment and perhaps escape injury. So with pathologic adaptation, that is what happened. They provide the cells with the ability to survive in their environment regardless, and perhaps per that provision, they may be able to escape injury. But with cellular adaptation, is a state that lies intermediate between the normal unstressed cell and the injured or overstressed cell. So the normal cell, if it is unstressed, it is normal. If it becomes a little bit stressed, then let's deal with the stress. If it becomes overstressed, let's deal with the stress. If we are not able to deal with it, then we die. So we have 5 main cellular adaptation processes. That is what I told you. So cell can adapt themselves undergoing 5 different conditions. So if a cell is injured, they may 1, become hyperplasic, or decide to become hypertrophic, or decide to atrophy, or become metaplasic, or become dysplasic. Cell may go through any of these processes, or sometimes they can even pick a lot of these processes. Let's say 2 of these processes, 3 of these processes, any form for which they wish they can do to be able to escape the injury. That is what they do. So most of the time, hyperplasia go hand in hand with hypertrophy. So we'll be explaining them one after the other. So this is what we are talking about. So what you see in the middle is the normal cell, the normal bronchial epithelial cells. Okay, so the cells that are found within our bronchioles. This is how they are. So you can see the various organelles and the nucleus that is found in the cell. If a cell becomes hyperplasia, so you see the normal cell. So now they have divided into 3. So they have increased in number. So this is the normal cell. Now they are 3. So now it was 1 cell which has become 3 now. So now the cell has increased in number. This is hypertrophy, the B. If a cell increases in size, we term it as hypertrophy. So now look at the normal cell. And now look at how it is swollen. So we call this hypertrophy. So increase in the size of a cell, we term it as hypertrophy. If a cell shrinks, we term it as atrophy. The cell has atrophied. So atrophy is shrink, hypertrophy is swelling or increase in size, hyperplasia is increase in number, and metaplasia. So look at the size of the cell, the shape of the cell. You see, it's like squared, cuboid, but now look, it's becoming like round in nature. So now when the structure or the shape of a cell changes, we term it as metaplasia. With dysplasia, so you see what is happening here. You see the nucleus. Now the nucleus has become bigger. Endoplasmic reticulum, ribosomes, so now some of them have even diminished. Some of the organelles have diminished, meaning that if this was performing a specific function, because this one has inadequate of these organelles, the function of this was going to change. Do you get it? So when the structural morphology of a cell changes, we term it as what? Dysplasia. So in adaptation, we have atrophy, hypertrophy, hyperplasia, metaplasia, and dysplasia. Hyperplasia, per definition, I already said, is an increase in the number of cells in an organ or a tissue. So let's say that if a cell is supposed to produce 4 daughter cells and it produces 8 daughter cells, it has become hyperplasic. It has increased in number. So hyperplasia can only occur with cells capable of synthesizing DNA like epithelia and hematopoietic and connective tissue cells. Examples are the nerve cells, the cardiac, and the skeletal cells have little or no capacity for hyperplastic growth. So cardiac cells do not increase in number. Nerve cells, as I told you, they are permanent cells, they do not increase in number. Skeletal cells, osteoclast cells, they do not increase in number. But we have certain examples such as a lactating breast. So when you are pregnant, the size of your breast is smaller. Immediately you give birth or during the processes of pregnancy or development of pregnancy, you see that the breast will be increasing in size. Okay, meaning that the lobes, the cells that are found within the breast are multiplying so that they can open up and breast, or let's say lactation, proper lactation can be initiated. Hypertrophy, an increase in the size of cells, and with such change, an increase in the size of the organ. So here, the size of the cell is going to increase. Physiologically and pathologically, they may increase. So physiologic growth of the uterus during pregnancy involves both hypertrophy and hyperplasia. And I told you earlier on that hypertrophy go hand in hand with hyperplasia. And as we all know, we get pregnant in the uterus, not the stomach. So it is the responsibility of the abdomen to be able to stretch to help accommodate the fetus in the uterus. So whenever there is pregnancy, that is development of the fetus, it is the responsibility of the uterus to increase in size. So for example, a non-pregnant uterus weighs about 60 grams, but a pregnant uterus weighs 1,000 grams. So let's look at the difference, 60 to 1,000 grams. So there's a wide difference. So meaning that it has increased in what? In size. Pathological cause, increased workload, hormonal stimulation, and growth factor stimulation. So hypertrophy of the heart, the most common stimulus is chronic hematodynamic overload. So let me give you a typical example. The people or the guys who gym or the ladies who gym. If you have a single room and you are going to buy a gen or a generator, I'm not sure you are going to buy a very big plant. It's a small generator that you need for a single room. But when you move to a mansion, let's say a 5-bedroom house, that small generator cannot be able to power the 4-bedroom house. So it is our responsibility to be able to change the generator to a bigger plant so that it can power it. That is what happened. When you are normal, you have not started any exercise. Your heart is at its normal rate because that is the norm that your body requires. But whenever there is an increase, when you try to exercise, meaning that you are going to open up certain muscles so that the heart is supposed to pump blood to the various parts of the body. So as you are increasing in size, it is the responsibility of the heart also to increase in size to be able to meet the demand of the body now. So therefore, the heart will become hypertrophic. It will increase in size because now you have moved from a single room self-contained to, let's say, a 5-bedroom house. So you need a new plant. So your heart will have to become hypertrophic whilst you are exercising and increasing your body weight. and mass. But the problem we have with fat people is that they don't exercise, and then they are increasing in size, and their heart is small. So it's like you are using a smaller generator for a bigger house. How can it power it? That is why a lot of fat people have a lot of conditions. So if they are being compensated with the increase in heart, then they can have a proper rate. The relation between hyperplasia and hypertrophy is that although hypertrophy and hyperplasia are two distinct processes, frequently both occur together, and they will be triggered by the same mechanism. So whenever there is a possibility of increase in the number of cells, then there's also a possibility in increase in the size. So as we use the breast as an example, if the breast tissue are increasing in size, certainly if the meaning that there is hyperplasia, meaning that the number of cells are also what? Increasing. So this is the normal heart. So as you can see the muscles of the heart. So these are the chambers. You can see the muscles over here. So this is a normal heart. This is a hypertrophic cardiomyopathy. So you can see over here the muscles. They have thickened, which has increased the size of the heart. So in case you are asked, which of the following organs can increase or can go through hypertrophy, then you can name the heart. Atrophy, shrinking. So you can see the left heart small here, which is normal. You can see the striations. You can see the right one here. You can see it is shrink, and look at what is happening. See, it is shrink. So you see the striations over here, they are smaller, and then they are more as compared to this one. So acquired loss of size due to reduction of cell size or number of parenchymal cells in an organ. So when there's a reduction in the size or a number of parenchymal cells in an organ, we're looking at what? Atrophy. So meaning that it is shrinking. Physiologic atrophy. So we talk about physiologic atrophy and pathological. So a normal process of aging in some tissues, which could be due to loss of endocrine stimulations or atherosclerosis. Atrophy of the lymphoid tissue in lymph nodes, appendix, and thymus. So atrophy of gonads after menopause. So your gonads will be shrinking. Atrophy of the brain with aging. So as you are aging, your brain will be atrophying, to becoming smaller, smaller, smaller. That's why it is susceptible to certain conditions, okay? Amnesia and all this. Pathological atrophy, starvation atrophy. When you starve some of the organs or cells, they shrink. Ischemic atrophy, when some of them lose blood supply, they shrink. Disused atrophy, if a cell or tissue is not used, it doesn't involve in a specific activity, it atrophies. Neuropathic atrophy, the neurons, when they are not sending enough impulses to the area for them to perform the activity that they are supposed to perform, they atrophy. Endocrine atrophy, when there are certain endocrine glands that are supposed to send fluid to an area for them to develop very well, they atrophy. Pressure atrophy, when they have too much stress at a specific cell. And idiopathic atrophy, the cause is unknown. Metaplasia. Metaplasia is a reversible change in which one adult cell type is replaced by another adult cell type. So as we saw in the diagram, it was like a cube, but now it was becoming like a circle. So meaning that as a complete replacement, that is not what the cell was, but now it is changing. I mean, it has completely been replaced by another. So meaning that it's the same cell, but it has to change. So it will move from its normal place of embedment and change just to suit the conditions of the stress, so that after that they can replicate. So causes may include changes in the environment, irritation or inflammation, and nutritional deficiencies may also happen for a cell type to be replaced by another cell type. So let's look at types of metaplasia. So we can have epithelial metaplasia and mesenchymal metaplasia. So for example, squamous metaplasia. So people who smoke happens to develop this squamous metaplasia. So changes in the bronchus, uterine, endocervix, gallbladder, prostate, renal pelvis, and urinary bladder. So when you are smoking, there are epithelial cells that are lining the smooth cells that are lining there. But as you smoke, those smooth cells are supposed to just move and turn into squamous epithelium. Okay, so they'll be changing so that they can suit the individual smoking. Because with smooth cells, smooth epithelium, they cannot contain whatever smoke that may get access into the bronchus. Vitamin A deficiency, squamous metaplasia in the nose, bronchi, urinary tract, lacrimia, and salivary glands. Columnar metaplasia, intestinal metaplasia is in healed chronic gastric ulcers and Barrett esophagus. So in such an instances, there's going to be changes. Mesenchymal metaplasia, osteometaplasia, that is bone cell changes, cartilaginous metaplasia, cartilage changes. So this is what I was talking about earlier. Okay, so this is schematic diagram of columnar to squamous metaplasia. So it was from columnar smooth epithelium to squamous metaplasia. So this is what happened. This is the basement of every cell. Every cell is supposed to have basement. And after the basement, that is where the normal columnar epithelium cells lie or reside on it. So as smoking continues, meaning that the cells will be changing. So here there's supposed to be metaplasia because the cells over here cannot contain smoke. So it will change. So you are going to have reserve cells. And as a matter of time, the whole normal columnar epithelium will change to squamous metaplasia or squamous epithelium. Dysplasia, disordered cellular development, also referred to as atypical hyperplasia. Epithelial dysplasia is characterized by cellular proliferation and cytologic changes. That is, increased number of layers of epithelial cells, disorderly arrangement of cells from basal layer to the surface layer has to be solved. The nucleus, some of the organelles that were found in the cell some of them were even running away, we couldn't find. Loss of basal polarity, that is nuclei lying away from the basement. We talked about all those things. Cellular and nuclear pleomorphism, increase nucleocytoplasmic ratio, nuclear hyperchromatism, increase mitotic activity. So all these things will be happening so far as dysplasia is concerned. The two most common examples of dysplasic changes are the uterine cervix and then the respiratory tract. So the uterine cervix will be changed in their morphological way. So the difference between dysplasia and metaplasia, nature. So with definition, you see, the cellular development may be accompanied with hyperplasia and metaplasia. The change of one type of epithelial or mesenchymal cell to another type, that is what we term as metaplasia. Okay, so it is a full or a total change outright. Types. So there's epithelia, which is squamous and columnar in metaplasia, and mesenchymal, which is osseous and cartilaginous. But when we come to dysplasia, only epithelia. Nothing happens to it. There is no change. Tissues affected. Most common affect bronchial mucosa, uterine, endocervix, other mesenchymal tissues such as cartilage and arteries. But with dysplasia, the uterine, cervix, and the bronchial mucosa is affected. Cellular changes. There's mature, so it means there's going to be a complete or an already mature cell that is coming to replace the other one. It is not now that you are going to nurture the cell that is coming to replace. No, an already mature cell to replace a cellular development. But with dysplasia, a disordered cellular development, that's the pleomorphism, a nuclear hyperchromasia, mitosis may happen, loss of polarity may happen, meaning that there are smaller cells that are supposed to start. With natural history, in metaplasia, reversible on withdrawal of stimulus. If you withdraw the excessive stress, there's a possibility of If you stop smoking, there's a possibility of those squamous cells coming back to their columnar epithelium back. But with dysplasia, may regress or removal of inciting stimulus or may progress to higher grades of dysplasia or carcinoma in situ. Sometimes they may regress, sometimes they may even lead into cancer. So on our next meeting, we would talk about reversible cell injury. So today, we've been able to start with cell injury, what a cell injury is, what causes cell injury, cellular basis of diseases. We have been able to say that every disease that happens, we are supposed to look into the cell, meaning that it is emanating from the cells. We've been able to look at certain adaptation processes or influences a cell may have if they go through injury. And we've been able to look at the 5 adaptation processes. We have been able to look out for the 5 adaptation processes, which we have atrophy, hyperplasia, dysplasia, metaplasia, and hypertrophy. So we have been able to look at all these things. Okay, so we have been able to notice that when a cell is injured, there's a possibility that it can be reversible. It can go back to its normalsm. So if all these things or all these adaptation processes come into being, meaning that they are able to go back to their normal cell and then react normally as there was no injury. But if the stresses are too much and then they are not able to cope with it, meaning that after a series of adaptation processes, they still become injured and then they go through irreversible cell change. And from there, from irreversible, the best thing that can happen to the cell is cell death. So on our next meeting, we'll be looking at irreversible cell injury. If a cell goes through a specific injury, how they do not come back, and then what happens to them after they are not able to come back. So thank you very much for listening. I hope we meet again.